Thanks for joining me today. I'm Patrick, coming to you from Vancouver, and this is Planetterrian Daily. Every episode, we dig into the latest peer-reviewed work that's quietly reshaping how we understand the human body, the brain, and the world around us. No hype, just the actual science and what it might mean for how we live. Let's start with something that affects virtually every adult who steps on a scale at their doctor's office. New research shows that BMI, the body mass index we've relied on for decades, misclassifies more than 1/3 of adults when compared directly against precise DXA body composition scans. The study took a large group of adults and ran them through both the standard BMI calculation and advanced dual-energy X-ray absorptiometry scans that actually measure fat mass, lean mass, and bone. The results were striking. More than 1/3 of participants ended up in the wrong weight category entirely. A surprising number of people labeled as overweight or obese by BMI turned out to have completely normal body fat percentages once you looked at their actual tissue composition. At the same time, others who carried dangerous amounts of fat, especially the kind stored deep around their organs, were being told they were healthy because their overall weight fell in the normal range. This isn't just a statistical curiosity. BMI was never designed to distinguish between muscle, bone, and fat. It's a simple height and weight ratio that says nothing about where fat is stored or what kind of metabolic stress that fat might be creating. Visceral fat, the kind that wraps around your liver and pancreas, is particularly problematic because it drives chronic low-grade inflammation, insulin resistance, and elevated risk for type 2 diabetes and cardiovascular disease. So when we misclassify people, we risk giving false reassurance to those who actually need intervention while potentially overtreating muscular, healthy individuals who simply weigh more than the charts suggest. My take is that this paper underscores a quiet but important shift that's been building for years. Clinicians and researchers are increasingly recognizing that we need to move beyond BMI toward routine body composition assessment or newer metrics that better capture actual metabolic burden. Things like waist-to-height ratio, DEXA, or even consumer-grade bioimpedance scales with improved algorithms could help. The real test will be follow-up work that asks whether correcting these misclassifications actually changes clinical decisions and, more importantly, improves long-term health outcomes. Until then, this is a reminder that the number on the scale, or even the category your doctor assigns, is only part of the story. What simple measurement or test do you wish would replace BMI in routine checkups? I'd love to hear your thoughts. Speaking of better ways to measure what's really happening inside the body, researchers have developed a fully non-invasive method to watch the brain's pulsation-driven clearance system in real time while we sleep. This is a big deal for anyone interested in long-term brain health. For years, we've known that the brain uses sleep to flush out metabolic waste, including proteins like beta-amyloid and tau that are linked to Alzheimer's disease. The process relies on the rhythmic pulsing of blood vessels and the flow of cerebrospinal fluid through spaces around the brain's blood vessels, a system sometimes called the glymphatic pathway. Until now, studying it in living humans required either injecting tracers or invasive procedures, which limited how much we could learn. The new technique changes that. It uses advanced imaging that can track these fluid movements without any tracers or surgery, letting scientists observe the entire clearance process in healthy people as they sleep. What they're seeing is dramatic. The waste removal system is far more efficient during deep, slow-wave sleep than during wakefulness or lighter sleep stages. The pulsations of arteries, the gentle swelling and shrinking of brain tissue, and the coordinated flow of cerebrospinal fluid all work together like a nightly cleaning crew. Most of us still think of sleep as passive rest, the brain powering down the way our legs rest after a run. This research reframes it as active housekeeping. Right now, as you're listening, those same vascular pulsations and fluid movements are likely helping clear the byproducts of a day's neural activity. The better and more consistent our deep sleep is, the more effective this system appears to be. From a longevity perspective, this is encouraging. Protecting high-quality, uninterrupted sleep, especially the deep stages, may be one of the most direct low-tech ways we have to support the brain's natural detoxification machinery and potentially lower the risk of neurodegenerative changes decades from now. It's another reminder that sleep isn't a luxury, it's infrastructure for cognitive health. While we're on the topic of protecting long-term brain health, another line of research adds biological weight to something many of us have felt intuitively. time spent in nature seems to physically reshape key brain networks. A synthesis of neuroimaging studies looked across multiple experiments that scanned people's brains before and after exposure to natural environments. The consistent finding was measurable shifts in networks involved in attention restoration, stress regulation, and emotional processing. These aren't just self-reported mood improvements, and we're seeing actual changes at the level of functional connectivity. The attention restoration theory has been around for decades, suggesting that natural settings give our directed attention systems a break and allow involuntary attention to take over. What's new is the ability to watch those psychological observations translate into changes in brain activity patterns. Areas involved in rumination and stress reactivity appear quieter after nature exposure, while networks supporting calm focus and emotional balance show stronger connectivity. For those of us thinking about mental resilience, cognitive health, and even healthy aging, this offers a practical, accessible lever. You don't need fancy equipment or expensive supplements. A walk in the forest, an afternoon in a city park, or even time spent tending a garden may be doing measurable work on the neural architecture that supports how we think and feel. The research is still early, but it's the kind of evidence that moves nature from nice to have to biologically relevant for brain maintenance. Staying with the theme of measurable biological signals inside the brain, another team has identified a brain network signature that appears to reliably predict whether someone with major depression will respond to antidepressant medication. Right now, treating depression often involves a frustrating period of trial and error. Patients may try 2, 3, or more medications over months before finding one that works. This new signal, detected through functional imaging, seems to indicate in advance which individuals are likely to benefit from standard antidepressants. If it holds up in larger trials, it could dramatically shorten that uncertain waiting period and help clinicians match patients to treatments more quickly and accurately. This fits into a broader movement toward precision psychiatry. Instead of treating everyone with the same first-line drug, we're starting to see the outlines of care that's tailored to individual biology. It's early days, but findings like this are exactly what we need if we want mental health treatment to become as personalized as some of the best cancer therapies already are. From fine-tuning treatments inside the brain to fine-tuning what happens inside individual cells, a research team at Postec has developed a clever, non-genetic platform that uses DNA in a completely new way. They've created a system where DNA is decoupled from its usual role as genetic code and instead acts as a programmable agent inside living cells. This allows precise control over cellular processes without ever editing the underlying genome. The advantage is potentially huge because you're not cutting or permanently altering DNA. The approach could be safer and more adjustable than traditional gene therapies. The platform gives scientists a new level of command over what cells actually do, turning genes on and off, directing protein production, or modulating signaling pathways with remarkable specificity. For synthetic biology and future targeted cellular therapies, this could open doors that have been difficult to walk through with older tools. It's a beautiful example of how rethinking the fundamental molecules we already have inside us can lead to powerful new capabilities. Another elegant piece of molecular engineering comes from the world of material science. Researchers showed that replacing just a single atom in a molecule can measurably change how phonons, the lattice vibrations that carry heat, move through a material. Phonon transport is what determines how well something conducts or insulates heat. By making that tiny atomic substitution, the team was able to alter thermal conductivity in a controlled way. At the nanoscale, this kind of precision is remarkable. It gives engineers a new dial to turn when designing everything from more efficient electronics to better thermoelectric materials that can convert waste heat into electricity. It's a reminder of how the smallest changes at the atomic level can produce outsized effects on macroscopic behavior. In an era when we're trying to squeeze more performance out of smaller and smaller devices, tools like this could prove valuable. Shifting from the very small to the very large, a new mission concept is getting attention for how it could transform our exploration of the outer solar system. The idea uses SpaceX's Starship for both orbital refueling and arrival braking at the destination, potentially cutting the journey time to Uranus from more than a decade down to roughly half that. Uranus remains one of the least explored planets in our solar system. We've had only one brief flyby, yet it has an extreme axial tilt that makes it scientifically fascinating. Its seasons are unlike anything else we see. Faster access would let scientists orbit the ice giant, study its atmosphere, rings, and moons in detail. and gather the kind of long-term data that a decade-long cruise simply doesn't allow. The concept is a clear demonstration of how reusable heavy-lift vehicles are expanding the possibilities for deep space missions. What once required decades of planning and enormous budgets might become more frequent and more ambitious. It's an exciting glimpse of how commercial space capabilities could accelerate scientific discovery. While we're looking outward to space, other researchers have been taking a hard look at the state of ecosystems here on Earth. A team at the University of Queensland has created detailed national data sets showing that about 30% of Australia remains free or nearly free of significant human pressures. At the same time, many other landscapes are becoming increasingly fragmented by roads, agriculture, and development. The maps are designed to give governments and conservation groups clear spatial data about where the last relatively intact ecosystems are located so they can prioritize protection efforts. This kind of high-resolution information is powerful because it moves the conversation from vague statements about losing nature to precise pictures of what we still have and what is most at risk. It highlights both the good news, that significant wilderness still exists, and the urgent need to act before further fragmentation occurs. Before we wrap up, keep an eye on the developing stories around brain imaging, sleep physiology, and personalized mental health treatments. Many of these signals are now moving from research labs into the early stages of clinical testing, and the next few years could tell us how quickly they'll reach patients. That covers today's science and health news. If you found any of these stories valuable, share the episode with someone who's curious about how the latest research might quietly shape how we live. I'm Patrick in Vancouver. Thanks for spending time with me. See you next time on Planetterrian Daily. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.